Okay, good afternoon, everyone. We'll go ahead and get started. Thanks for being here. This is Creating Robust, Maintainable Coded UI Tests with Visual Studio 2012. Before we dive into the content, I just want to do a quick housekeeping slide here. My team back in Redmond is the team that puts on these events. Obviously, it's a huge team effort. Lots of people around the world coordinate them. But our team back in Redmond is responsible for TechEd Europe, Build, PDC, and lots of other camps and events around the world. So I just wanted to say to everybody that's been tweeting feedback, thank you very much. We really do appreciate it. We really do monitor everything. We've got people in a secret location close by that are actually watching all of the streams that are coming by. In fact, we have TEE12 is just displayed up on the big monitor, so anytime you tweet something, we're trying to respond in real time. I also wanted to thank you guys for the great idea. We, due to popular demand, we are now going to be showing, oops, that's the wrong clicker. We're now going to be showing the Italy-Germany match tonight. So if you're interested in that, come by in this room at 8:45. And it's also going to include some beer and snacks as well. So that's our, yes. That's our thanks to you. So without further ado, let's now switch back and talk about coded UI tests. So quick show of hands, how many people have worked with coded UI tests before? Great, fair number of you. And so I assume the rest of you, it's pretty new to you, that's fine. I have to be honest, I'm having a hard time with this particular session trying to figure out exactly where to set the technical focus. I've done this session a few times and people have said it's not technical enough. And then 2 weeks ago at TechEd North America, I actually had a peer of mine who's on the coded UI test team, and he dove into kind of a 350, 400 level technical depth. And we found that he kind of lost a lot of the audience along the way. Some people really appreciated it that have been working with coded UI tests for a while. So my request, if you will, go ahead and fill out the surveys, of course. But if you have any suggestions for how I might be able to improve this talk to kind of tailor it to the broadest audience possible, please don't hesitate to send me an email, brian.keller@microsoft.com. I really want to make it the best type of content possible for you. Another quick poll. How many people were in my session yesterday? Few of you? Okay. I'm going to be talking about lab management a bit, but because most of you didn't see that session, I am going to recover some of that ground just to make sure that folks understand the capabilities and the value proposition around lab management. So stick with me if it gets a little redundant. I promise we'll get to some new stuff in this session. Okay. So for those of you I haven't introduced myself to, I work at Microsoft in Building 40 back in Redmond. We just got a brand new cafeteria there, so stop on by if you're in the neighborhood. I will buy you lunch. I've told this to thousands of people around the world, so someday I'm going to have to, they're going to cash in on that, but so far nobody has. I've been on Visual Studio for 10 years and 10 days now, so it's really great to be at Microsoft. I've never been prouder to work at Microsoft with all the innovation going on around Windows 8 and the new Surface devices. It's just a really exciting time for everyone. I'm on Channel 9. I put all of my content on my blog, so if you want to go back and run through the same demos that I'm doing this week, you can download a pre-configured virtual machine. It's built for Hyper-V, but I've seen a lot of people get it working on VirtualBox and VMware. It's a pretty easy conversion if you want to run it there. And it has about 18 hands-on labs and demo scripts, so you can go through everything from core TFS functionality to coded UI tests, manual testing. And the nice thing, of course, about the VM is you don't have to worry about breaking anything. It's already set up with application data and all the sample data you need to run through that. I've also written a couple of books, including a couple of new books on Visual Studio 2012 that will be coming out later this year. And so what I'd like to cover in this session is really a focus on how you can write better coded UI tests. It's easy to write your first coded UI test. You can basically follow through a wizard and kind of record as you go, as you'll see what I'll be doing in this session. But what I've tried to do here is try to capture some of the common pitfalls that people run into, because as we all know, writing automated tests are going to be the most fragile types of tests. The session I did yesterday was primarily focused on manual testing, and manual testing is great for a lot of reasons, chiefly because manual testers can kind of adapt and change to the application as it's changing underneath them. And you don't have that same flexibility oftentimes with automated tests. Now, the good news is that, as I'll point out in a few spots, there's a lot of robustness already built into the coded UI test engine. So we've actually been using this technology at Microsoft for about 10 or 15 years to test technologies like Windows and SQL Server and Visual Studio. And so we've done a lot of work in the core platform prior to even releasing it initially with Visual Studio 2010, just to try to make it robust out of the box for you. But there's obviously going to be some other stuff left up to you in the way that you build your tests and the way that you build your applications, and that's what I'm going to try to surface here for you. So in order to use this, you will need Visual Studio 2012 Premium or Ultimate. That's what gives you the ability to actually author tests. Anybody can run them. You just need to make sure that in order to author them, that's where you get the tooling support. If you're still using Visual Studio 2010, most of the concepts that I will show you today will also apply to Visual Studio 2010, but there have been several changes in the testing framework, number one, and in coded UI tests, and I'll point those out as we go. There are a few things that are better, and to be honest, there's a few things that we're still catching up on, and we hope to gain parity and then, of course, make better in the future. Part of the reason for that is if you've attended my colleague Peter Provost's sessions this week, you'll notice that we really overhauled the unit testing framework experience within Visual Studio. And along with that, there's a few tooling capabilities that have not yet been added to Visual Studio 2012 using the new platform, which did exist in Visual Studio 2010. They're relatively minor, but I will point them out as we go, and our hope is to continue to add those in subsequent updates on top of Visual Studio 2012. So that'll make more sense as we go through this. You will need C# or Visual Basic skills. The reason I say this is that there are test automation frameworks on the market and available as open source tooling that you don't really need to have coding skills in order to take advantage of. Coded UI test is not one of those, so you will need to have some coding skills in order to work with this. It's also something that works really well with Microsoft Test Manager, and I'll show you the workflow if you're already using Microsoft Test Manager to go from having manual tests and have those be kind of upgraded, if you will, to automated tests later on. If you want to take advantage of the lab management capabilities that I'll be showing you, you'll need to have Team Foundation Server. But again, that's not a requirement if you just want to build and run coded UI tests kind of on machines that you manage yourself. And then you'll need a testable application. That may sound like a no-brainer, but of course, given that the coded UI test engine itself relies on some of the accessibility hooks within the applications that you're building, you do need to make sure that the application type that you're using is something that will work well with our tool. Now, this is not a slide that I expect you to read. I know it's really small in the back, but I do just want to kind of talk about a few of the major buckets here in terms of the types of applications that we do support. This entire matrix is online in the MSDN library, so if you download my slide deck, you can follow this link here, which will actually take you to the latest and greatest information, which gets updated as we make changes to the platform support. But starting at a high level, pretty much any browser application that you're testing is going to work very, very well. We actually operate at the DOM layer, and so there may be differences in the types of bugs that you discover between, say, IE7 and IE9. And so it's important for you to start thinking about testing for those different types of browsers. Now, I will say that currently we're in a bit of a lurch with respect to our third-party browser support. We did a bunch of work in 2010 to make sure that we could test Firefox 3.5 and 3.6, and then almost overnight, what is Firefox up to? They're like Firefox 13 now. So they actually just changed everything out from under us, and we're trying to figure out how we can continue to provide great support for those third-party browsers. I will say we're working on it. I don't have any timing to announce right now, but we do have a lot of people who are looking at this space. And the idea would be that you would author your tests using Internet Explorer, and then you could choose the browser that you wanted to play them back in. And if there was a rendering difference, for example, between Internet Explorer and Firefox, then you could run the coded UI test twice, and you might catch a bug in one of those. So please stick with us for those additional browsers. Like I mentioned, we are working on that. Most of the Microsoft technology stack is very well supported. So Windows Forms, WPF, SharePoint, these are all supported quite well. A few of these do have some workarounds that are required. For example, with SharePoint, we have a blog post that details how you can work with SharePoint and coded UI tests, because some of the parameters and the page URLs within SharePoint are dynamic. So I'm not going to dive deeply into SharePoint because I realize not everyone in this room works on SharePoint. But if you are writing coded UI tests for SharePoint, make sure you check out that article. Silverlight is another one that we are currently working on. It's not currently in Visual Studio 2012, but if you need to write coded UI tests for Silverlight, then you can go back to Visual Studio 2010 and use Feature Pack 2, which adds support for Silverlight. So I don't want to get too far into the weeds with the platform matrix here, because again, all this information is online, but I did just want to call out a few caveats here. So let's dive into some demos here, and we'll create our first coded UI test. So the application that I'm using is really the world's most basic application. And the reason for this is I just wanted to keep it focused on a very simple application. So we're not going to be creating an application for a really complex or creating a test for a complex application, because everything I need to show you can actually be done with very basic applications here. So this is a WPF application, and if I say hello TechEd and hit go, then it should just return a label. So that looks like it's working okay. At this point, what I'd like to do is write my first coded UI test. So again, this is Visual Studio 2012. I'm using the release candidate. And one of the first things that you may notice when you start working with tests in Visual Studio 2012 is a difference from the way 2010 worked. In 2010, you actually had an option to select a test project, and then you could put any type of test that you wanted into that, but we didn't make any assumptions about the type of test you were using to start with. In 2012, we actually give you test projects for each type of test that we support in Visual Studio. And the reason for that is somewhat subtle, but it comes into the way that test settings work. And I'll show you that in just a moment. For now, let's just go ahead and select a coded UI test project, and I'll just keep the default name, which is fine. So this is creating my new project for me, and it will create my first coded UI test. It's going to ask me how I want to generate code for this coded UI test. And those of you that have done this a million times, I'm sure you've seen this dialog a lot. There's two different ways to create code. One is just to start using the application, and as you're using the application, you can record all of your actions. So I type this data here, I press enter, I click over there, and then you can add assertions as well. So along the way, you can say, make sure that this value is equal to this value that I'm expecting, and if not, throw an error message. The other way, as I alluded to, is if your testers are using Microsoft Test Manager. One of the capabilities of Microsoft Test Manager that I showed yesterday is as you're running your test cases, those testers can actually capture what's called an action recording as they go. That captures everything that they're doing as well. So they're clicking here, they're typing there. And so we give you the opportunity to leverage that as part of your coded UI test. So we'll take all of those actions that they would use to fast forward their test cases, and then we'll give you the actions as a starting point for creating a fully automated coded UI test. Now, the one thing that you haven't done in that situation is actually replace the tester sitting in front of the mouse and keyboard looking at the application and visually inspecting it. So at that point, the additional thing that you might want to add, of course, is some assertion logic along the way, just to make sure that all the values you're expecting match up. Now, before I start actually creating code, let me just cancel this and show you that the framework here for a coded UI test is really just about the same as the framework for a unit test. So I have test methods down here. This is actually going to be the main test method that will run all of our code in. And then down here, we also have other options, such as the ability for you to run startup tasks. So if you needed to initialize data before you started testing to make sure that a data grid rendered properly, this is where you would do it. If you needed to run cleanup tasks, this is where you would do it. There's other options as well, but this is certainly, if you're doing this with with unit tests already, then this should fit naturally with what you need to do. So what I'm going to do now is just place my cursor within this region and generate some code. So we'll go back to the test menu, and we can pull up that dialog to say that we want to use the coded UI test recorder. And then this is the tool that we're going to use to capture all of our actions moving forward. And so what I can do is I can just click this red record button, and I'm going to turn on this second pane, which shows me all of the actions that are being captured. And then I'm just going to start testing my application and interacting with it in the same way that I would expect a user to. And so I'm going to click on the shortcut, and then I'm going to press Enter to launch my application. And one of the things that you may have noticed if you're watching our recorded actions is that the first time I clicked the shortcut, in fact, let me do that again and just show you. I actually meant to slow down a little bit there. I can just go back and delete these actions as well and basically start over. So if I start recording again, and I left-click on that icon, notice that it's kind of grayed out, but it says click the test app shortcut list item. Now, I know that's nothing fancy, but the next thing is actually kind of cool. When I press Enter to launch that application, what it's done now is it's actually collapsed the click and the enter to determine my origin of intent. And that's really important. What I really wanted to do here was launch that application. And that's just one of the ways in which we try to capture what you're meaning to do, as opposed to explicitly the actions that you're taking. Now, why do we do that? Well, let's say that you deployed this application out to a lab machine. You don't want to have to remember to copy a shortcut to the desktop every time you run this on a lab machine. You just want to deploy it into some directory, and we'll capture the executable path, and then you can launch the executable. So you'll see this throughout the framework. Anytime we can do this type of simplification, we will. The next thing I'll do is just go ahead and type hello TechEd and click go. And then we'll close my application. And sometimes when I have KVMs plugged in, which is the keyboard video mouse setup they have, it captures additional actions. So you won't see that, but I'll go ahead and delete that from the recording. And then we can go ahead and generate a method for this, which is just test my app. OK, so that should be the world's simplest test. At this point, what I can do is just run that test if I want to. And if you've seen the new Unit Testing Explorer within Visual Studio 2012, what you'll see in a moment is that we'll build my project, both my test project and my application project for the first time, and then that test will show up in the list, just like a unit test within your solution. Now, this is part of the distinction between coded UI tests and unit tests in one category and web and load tests in another category. If I was to create a web and load test project, you would actually see that those web and load tests don't show up in the Test Explorer window. And those actually do show up in a different window within the traditional window, which is the test runner that you would expect from Visual Studio 2010. And some of the differences, or some of the reasons for that, are quite subtle. But one of the main differences there is that when you're using web and load tests, we rely on the traditional test settings file to describe attributes like what browser do you want us to emulate when you're running the web test, or what kind of network settings do you want to simulate when you're running a load test. And so that's why, by default, coded UI tests and unit tests have their own unique projects, and they don't have a test settings file. Now, one of the things that you could do at this point is you could come over to Solution Explorer, and you could add a test settings file. So I'll add a new item here and just add a test setting. And then once I have this test setting, then I can go into it and start to define things like, what data do I want to automatically collect when I'm running my tests? Maybe I want to turn on IntelliTrace or code coverage or some other attribute that's interesting for me to capture while my tests are being run. But again, by default, coded UI tests are going to run in this new test runner experience, which is meant to be very streamlined, very fast, and doesn't load all of these additional test settings. But I just wanted to show you that that information is there if you need it. I'll just go ahead and delete it for now. So what you may have seen is that my application ran and it worked correctly. Let me show you what's happening behind the scenes, because really everything that I did got collapsed to a single test method. If we go to definition on this, then you'll see where the magic is taking place. The first thing that you'll notice is that when we launch the application, we actually have two parameters that we pass in when we launch the application under test. The first of these is the full path to the application, and the second of these is a fallback path, an alternate exe path. And so let me go down to further in this file, and you'll actually see where those get defined. Now, this is a little bit of a misdirection that sometimes confuses people when they first start working with coded UI tests, because you have this test runner that ends up having one or more actions or one or more methods that then call up into these smaller, more granular defined blocks of actions and assertions, and then all of the values that they rely on, like the URL for the website that you're going to launch, or the application's executable path, or the string that a tester is going to type into a box, all of that's actually stored somewhere else. And so it tends to get a little bit overwhelming at first, but there's a good reason for that. The reason that we do that is to make it very easy for you to go back later on and, using code, override values. A good example of that would be if you were to deploy an application out to a lab-managed environment, as we'll do later on. One of the things that you might want to do is override the URL for the website that you're testing. Because in your test environment, you might have a different URL or IP address than what you have in your production or your development environment. And so this makes it really easy for you to get in and do that. And so here what you see is the full path to the executable down here, which is in the release folder of my solution. And then we also have a relative path that gives you a fallback using the relative location of your Visual Studio folder. And so again, you get all that by default. There's not really a whole lot you need to pay attention to. And in fact, this is a designer.cs file, so you should not edit this file directly. Instead, I'll show you how you can make changes to this later on. The next thing that I wanted to point out here is another thing that a lot of people wonder about when it comes to the coded UI testing framework. Notice here that I clicked on the button to say go, which took the text from the text box and populated that in the label. And so there's that UI go button. That's straightforward enough. But then we also have these points that are being passed in, X, Y coordinates. A lot of people look at that and they say, gosh, this is probably a really fragile testing framework because you're using X, Y coordinates to actually find the controls. So what if I'm on a different resolution? Or what if I move this control around later on? And the reality is those points are only used as a relative position within the control that you're clicking. And so the way that we actually find controls on a page are using what are called search and filter properties. Filter properties are only used for web applications. With search properties, we basically look at the entire hierarchy of your UI, and then we look for controls that match specific names or specific types of controls. So if you're searching for a button and there's only one button on the page, then we're going to use that button. If you're then looking at a page and it has multiple buttons, then we're going to fall back to the next parameter, which might be the name of that button. The reason we do it in that order is that if you decide later on to change the name and you only have one button on your form, we can still find it. If we were to search for name first, obviously we wouldn't find that. So I'll show you how we reorder that later on if you need to customize it, especially if you're using applications which dynamically generate controls. That's especially important to find or to understand the way that search and filter properties work. Now, the filter properties allow you to take that set of matching controls that you found on a particular web page. So let's say that we're looking for columns within a table, and you might find 50 columns within a table. And the filter properties then allow you to pare that down until you find exactly one match, which we'll assume is the value that you want to use. And so I'll show you that in a little bit. The reason that we do that for web pages is that on a rich client application, like I'm using here, WPF or Windows Form application, you're guaranteed to have a unique control by the time you walk the hierarchy and then walk the specific names that you're using. But in a web application, you're not guaranteed simply because you're not required as a web developer to assign names to all the different controls on your page. That would be nice, and that's something that if you can, you should encourage the application developers building those websites to assign some name that you can key off of, but that's not always the reality. So we give you those filter properties to allow you to condense that to a single control that you can match later on, okay? So the reason that we actually, getting back to the XY coordinates, the reason that we actually care about XY coordinates in the first place, for a button, it doesn't matter. You're just going to click the button. It doesn't matter if you click the upper right or the lower left or the center. It's going to do the exact same thing. However, there's some controls, like this split button here, where it makes a very big difference where I click. This is actually a single control right here. So if I was to click on this side of the button, it means a very different thing than to click on this side of the button. And that's why that's important. And there's some heuristics behind the scenes. You might say, well, what happens if I, clicked on the far right and then I resize the button to be too small? There's some heuristics behind the scenes in terms of the coded UI test engine trying to do the right thing in terms of clicking on the relative position that you originally clicked on. The reality is that if I was to resize this split button, I could get myself into a situation where I might need to go in and redefine the XY coordinates. But the good thing about that is that most of the time, you don't need to worry about that. So again, I'm focusing on some basics here because I think the basics are really what adds up to making sure that you understand the testing framework and you can build reliable tests over time. The next thing that I want to show you is the way that you would go through and actually edit that designer file. With Visual Studio 2010, we shipped a designer called the Coded UI Map Designer as part of Feature Pack 2. And you had to have an active MSDN subscription to go download that. Now what we've done is we've actually baked that into the product because it really is a very integral part of the way that you work with and maintain coded UI tests. And so what you can see here is that I've launched the coded UI map just by double-clicking on that UI map file, and then it's listing out all of the actions that I recorded as I went through. Now, this can be helpful as starters for just deleting extraneous actions. Like I showed you an extraneous action that was introduced by the KVM up here. And so I deleted that while I was recording the application, but you could also come back and delete it after the fact. Another common one that you may want to clean up is if you're recording the application and you're pressing tab, tab, tab to go to different fields within a form that you're filling out, you usually want to go through and delete those extraneous tabs. And the reason for that is you might find yourself later on as an application developer adding focus to a specific tab within the form so that when that control has focus, you do something. You pull down a drop-down menu or something like that. And you don't necessarily want to do that in your coded UI tests. So where possible, you should delete those extra steps that you know are not going to be necessary for your test in the long term, and then instead just simplify specifically on the types of actions that you need. So you may wonder, well, okay, so if I don't tab from this first name column to the last name column, how do we get the value in? We actually just map the value of the string that the user would have typed directly into that cell. So we try to do that behind the scenes for you. The other thing that is sometimes helpful is to come in and actually refactor this single method that I recorded during my coded UI test wizard and refactor that into multiple methods so that I have more flexibility to evolve this over time. And that, quite simply, is just right-clicking, saying split into a new method. It's giving me a warning saying that I need to go back to my test harness and actually wire up exactly which methods I need to call. So I'll show you doing that in a moment, but let's go ahead and say OK to that. And then we'll split it one more time. And what I'm doing is I'm basically just creating 3 different methods. The first one we'll rename to launch my app. The second one we'll rename to test my app, and the third one, close my app. I'm feeling particularly creative today. So once we save this, of course, we now need to come back to the test harness and actually update this to call the appropriate methods. Another thing to point out on the UI map file is that these methods are actually listed purely in alphabetical order. So we don't know in what order you're going to call them. It just shows them in alphabetical order. So that's something that I get a lot of questions about. The other half of this page is where you see the UI controls that we found when we were testing your application. So this one is pretty straightforward. We've got the high-level window up here for my application. It has a couple of controls that we interacted with, the text box and the Go button. And then there's a title bar where we actually accessed the Close button. And so those are just the controls we interacted with. And we can now access those programmatically based on the properties that we understand about those controls. Now, if you wanted to later on programmatically interact with a button that wasn't interacted with when you recorded your test, you'll need to manually launch the Coded UI test recorder like we did previously, and you can actually select the controls and add those specifically to your UI map. And then from there, you can access them programmatically to say, click this button, you know, every time this particular value shows up or that kind of thing. But by default, we're just going to capture the ones that look interesting. Now, the way that we find a control using the search and filter properties is stored over here in the properties for this specific control. And so you'll see down here, for example, let me just clear up some real estate. You'll see that we have a search configuration. Search properties, actually, is what I was looking for. And this is where I was saying earlier that we actually go from top to bottom doing a breadth search for a single control that matches. So we're going to look for any editable fields that match this particular accessibility framework that are called My Text Box. And so from there, we should have exactly one match. And if we don't, then it's actually going to fail the test, by default anyway. We don't always fail the test. In fact, if you select an action over here, then you have the option of overriding the continue on fail event. And so by default, if we can't execute an action or we don't find a control that we're trying to assert on, something along those lines, we'll fail. And once you fail the test, you're out of the test, just like you are with a unit test or another type of test within Visual Studio. Now, there are times when you may not want to fail right away just because you couldn't find a control. A really good example of that is that if you've ever been on MSDN and you get prompted for that survey like every 3 times that you visit, I know it's quite annoying. I don't know who to tell to turn that thing off. But if you're like me, then it seems like every time you open up the MSDN library, you're prompted to fill out a survey. That's not always going to happen. And so if you're writing a test to validate that the MSDN library tree looked correct, then you would want to make sure that you have an action in here that if that dialog pops up when it first opens, you want to go ahead and dismiss it. But if it doesn't find that dialog, then you just want to continue on error because it's only going to show up once in a while. Another good example is if you're configuring your lab environments. Internet Explorer and other browsers will often ask you to do things like remember form passwords, or are you sure that you want to, provide your secure data to this form, and you want to say yes, I'm sure, and don't show me this again. That's another good example where in order to make your tests a little bit more robust in other environments, you can record those actions conditionally and then turn them off within the properties grid. Notice also that I can come in here and override things directly, like the file name that we're going to be launching. And so this is pretty straightforward once you start looking at it, but there are just a few nuances to understand there. Now, instead of overriding everything programmatically, what I'm going to do instead is actually, or directly within the properties grid, what I'd like to do instead is override this programmatically. And what I'll do is I'll actually start by overriding the string value that we type in. So let's say this.UIMap, And when I test my application, there's a method in there that I showed you earlier, which is where all of my parameters are stored. And so when I typed hello TechEd, I actually want to override that with my own value now. Now, every time I use zoom it, I'm getting that IntelliSense is dropping away. And then the field that I want to override is actually just what we type into the text box. And instead, we'll say, goodbye, TechEd. So if I build this solution and run that again, we'll just verify that my refactoring didn't break anything and that we now have the string goodbye TechEd. Okay, so that's not very interesting so far. The next thing we want to do is we want to make sure that we're actually asserting some values on this form. So I want to make sure that when we type in hello TechEd, that it actually shows hello TechEd. And so the next thing I might do is add an assertion. And the way that you would add an assertion is you just, again, place your cursor where you want to generate the code. And then you click on test, and you say use the coded UI test builder. And then what I like to do at this point is just put the application into the state that I want it to be before I start recording anything. And then at this point, I can just grab the crosshair and I can drag and drop onto the field that I want to validate. And this pulls up a property bag that shows me all the fields for that specific control. And so for this control, we have display text, which is set to goodbye TechEd. And so I might want to validate on that. You can really validate on anything that you want that shows up within this property bag. So you could validate that this control is editable, that it's enabled, that it doesn't or it does have focus. So there's really a lot of things that you could add as an assertion. And you can add multiple assertions even in a single step. So when I add this assertion, one of the things that's brand new for Visual Studio 2012 is that we give you this message on assertion failure. That's something that I used to tell people to override manually when they wrote tests with Visual Studio 2010. The reason for this is that if you're a test engineer and you come in the morning to investigate a bunch of failed coded UI tests that have been run against your build environment, you're just going to see that, control foo does not match control bar unless you give some hints to the test engineer about exactly what they should be expecting here. So rather than just having them see that this control doesn't match this value, what I'd like to do instead is say the label does not match what the user typed. And at that point, you'll see in a moment when we fail this or force this test to fail, what that looks like. And once you're done, you can add more assertions here. I'm just going to add the one, and we'll call it validate label and add that back to our project. Now, what I'd like to do is go ahead and force this test to fail. So what I'll do is actually override what we're looking for in the validate label with a different value from what we're typing in. So we'll just say this.UIMap, validate label expected values, and then what we're searching for, we'll set that equal to hello TechEd. And so, of course, we would expect these to fail. We'll go ahead and run these tests, or run this single test, rather. Oh, what did I miss? Oh, semicolon. Thank you. Failed for a different reason. Okay, so my test failed. When you highlight that test, it's going to tell you exactly where within your test that it failed, exactly when, if your application threw an exception, you could click to that to see not only the test code, but the application code as well. And then you also get this output with a few helpful things. Now, by default, this won't be what the view is that you get for your test, but instead what we've done is we've actually enabled a new rich error log that I have enabled, and I'll show you how to enable that within Visual Studio 2012. It's probably hands down the single biggest helpful thing that we've added to Visual Studio 2012 for coded UI tests. And so when this test fails, if I open up this UI action log, it's actually going to give me a really rich view into exactly what was happening within my test. Now, I have this turned on for all actions at this point. If you wanted to trim this down to just the failed events, you could do that just by setting the trace setting that I'll show you in a moment. But I like to see everything. And so what we see here is that when we launched this application, this is what my screen looked like. And so actually, that's right before we launched the application, so it's not on the screen yet. When we typed goodbye TechEd, this is the field that we typed that into. And then finally, once we get down here, where we're actually throwing this assertion, this is what the screen looked like. And so here we can see that it didn't actually match what we were looking for because we were looking for hello TechEd. And then here is where we threw that additional assertion information just to help the user understand or help the tester understand exactly what failed. So this makes it really easy as a developer when you're debugging your coded UI tests, or as a test engineer who's responsible for picking these up, to quickly understand exactly what's going on. It's also a nice log for you to refer back to look for things that maybe your coded UI test didn't even test for. So I could look at these screens as a tester and say, you know what, that's actually formatted incorrectly. Or there's another error happening on the page that we didn't add an assertion for. And at that point, it really gives you kind of that best of both worlds between having great test automation, but also giving the tester the ability to go back and look over the shoulder, if you will, of the computer as it's testing, so that you can look for other errors that you may not have thought to add assertions for directly, or if you just didn't even have time to add those assertions. Now, by default, like I mentioned, this won't be enabled. If you want to enable this, you actually have to come into the Visual Studio 11 Common 7 IDE and then drop down to this file called qtagent32.exe.config. I know, it's a bit of a bear. Once you do it once, it's all set up. But we're going to work on making this a lot easier in the future. So if I open up this file, then I'll show you the 3 things that I did to change this. The first thing that I did is I changed this EQT trace level to 4. In the RTM bits of Visual Studio 2012, 1 and 2 will only capture errors, and then 3 and 4 will actually capture everything that's taking place. So it just depends on how much data you want to collect. There's very little overhead for this, so I always recommend just turning it up to 4. And then down here, I had to add 2 additional values. One is to enable the HTML logger, and one is to enable that snapshot information where you see the little screens in line. And this is all documented online. And the other thing that we want to do moving forward that I just filed a bug on is to make this easy for you to set within your project or solution, as opposed to setting on the machine where you're actually running the test. So today, if you were to set up a lab-managed environment and you wanted to turn this on, you would actually have to find that same config file on the machine where the agent is that's executing those tests and make these same changes. Obviously, that can be a pain if you're trying to maintain a lab where there's lots of machines that are potentially running your tests. And so in the future, we'd like to enable this. So by the time you get around to trying this out, it may have changed. Just check the documentation on that. Now, the other thing that you have the option of doing, which is, maybe helpful depending on whether or not the particular screen that you are validating on is visible at the time that you're running an assertion. The nice thing about this is that it just captures the entire screen, but sometimes you might want to capture a specific form that may be behind another form. And in order to do that, it's actually pretty straightforward just to capture images right within the tool. So I could come in here and say something like, image pic is equal to, and then what you do is you basically point to the control that you want to test on. And so here I have my application window, and I can say capture image. And then it's just a matter of saving this out. keep forgetting semicolons. Feel free to throw stuff at me every time I do that. The test context that I'm using right here to add a result file, that actually has a lot of really helpful methods on it, or a lot of helpful member variables on it. And there's a lot of different things that you can override, like what the timeout values are for your particular test run. Most of the time, the way that the test run executes is it will actually execute as fast as it can once it sees the UI thread being finished. And so that works most of the time, but if you needed to have an application that every 15 seconds fetches new data, and you just have a sleep timer that's waiting in the background to fetch new data, if you wanted to test that application after 3 minutes to make sure that the data looks correct after it had been refreshed multiple times, in that case, you'll want to insert manual delays into your application. And you can do that from the UI map just by right-clicking and saying inserting a delay and just programming the number of milliseconds that you want. So if I run this test again, you'll see the result of that file that gets saved. And again, it's just focused on that specific control that you're validating. You could also go down further in the hierarchy if you wanted to say, just give me an image for this panel or something like that. Oh, it didn't. Let me make this pass, actually. So there's a file that just gives you that specific control. So that's sometimes nice to have. And it also, of course, has better resolution than looking at that full screencast. OK. Now, I mentioned that there is a couple of things in the Visual Studio 2012 bits that are actually take-backs from what was in Visual Studio 2010. The next thing I'll show you is actually one of them. If you've used the data binding capability for a unit test in Visual Studio 2010, that feature that allows you to point a unit test at a CSV file or a database or an XML file, it pulls up a really nice wizard. It gives you a connection string at the end of that, and then it basically iterates through your test as many times as it needs to based on the number of rows that are within that database or CSV file. That was really helpful just for pointing at a method and just automatically decorating it, but that, unfortunately, is not currently in Visual Studio 2012. I remind Peter Provost of that every time, so I know it's on the backlog, and I know it's something that he intends to deliver in the future. But for now, if you wanted to data bind this particular test, there's a couple of steps that you would do manually. The first of these is just to point at the particular item that you want to data bind to. And so I actually have a CSV file that I will point to, and I'll show you what that looks like. It's pretty straightforward. And so I've added that to my solution, and then it basically just has 2 rows of data, input and output, and all the different values that I want to validate against. And so the one thing that you will need to remember to do that the wizard did for you automatically is you'll have to change the properties of this guy so that it copies it to the output directory. Otherwise, it will never actually, oh, you know what I did? I added that as a solution item. Sorry. I want to add that as a project level item. You need to make sure that this copies as part of your build. And then the only other thing that you have to do is you have to then handcraft the data connection string. And so what you'll do is you'll end up replacing this test method or adding to the test method. And so here what you can see is that we have the data source is using the CSV file reader. Obviously, this would look different if you were connecting out to a SQL Server database or an XML file. That again, is documented online, how to actually craft these connection strings. What I do is I sometimes cheat. I'll just use Visual Studio 2010 side by side, pointed at the file that I need, and just copy and paste that. And then there's the table within that CSV file. And then this is another thing that you might want to change, is to change the data access method between sequential and, say, random, so that you get better test coverage. Obviously, some tests would expect you to enter things in a certain order, but if you wanted to add a different slice of data every time, or a different path down your data every time you ran your test case, then you could change that to random, for example. The next thing you need to do is you just need to point the columns of that data to the rows that you'd like to override. And so the first thing that I'll do is I'll just say that we want to set the UI edit box to test context.data row input. And then we'll do the same thing, but for output down below. And so now when I run this test, it should run through for each row of data that's in there. Now, the nice thing about going from a manual test within Microsoft Test Manager, if you've used Microsoft Test Manager, then you know that you can actually bind a test case to multiple rows of data just by typing in the data down below the test case. And then that's really helpful because, number one, when you create a test, or when you create an automated coded UI test based on that test case, we automatically do that data binding back to your Team Foundation server for you. And the other thing that we do is allow the manual tester now to go in and update that data. So they don't have to be a technical skill set at that point. They can say, hey, we need to make sure that we're testing for addresses in the Netherlands and the UK, so they can go in and self-maintain that file without getting a technical asset involved. And so at this point, we ran through this again, and I want to show you another. Oh, it's still running through. Didn't mean to disturb you. It's running really slow. I think that's a symptom of my virtual machine and all the snapshots that I have right now. Runs a lot faster back at home. Okay. So that ran through again. And if I take a look at that output, I actually didn't name my files anything different. So I'm going to have 3 different BMPs. Of course, you would, when you name this, you would be a little bit more creative. But here you can see an example of where you would actually discover a bug by going back and inspecting those snapshots later on. We asserted these values. They looked correct to the computer, but to a manual tester, clearly we can see that we're cropping. So we might want to consider how we display this label after a user types it in. So that's just a really nice thing that you can do. I've also seen people take the images that they generate from the coded UI tests and just generate HTML docs like we do for the rich action log. So depending on whether or not the rich action log meets your needs, or if you want something that's a little bit more custom, you might want to use the direct image approach just to put that right into the test results document. And that can be really nice for even communicating with your stakeholders as well, because you can go back to your stakeholders at the end of the week and say, here's all the functionality that you asked us to deliver, here's our tests that are running through that in an automated fashion, and here are all of the images that show you what each one of the screens look like, and you can hand that off to them, and they don't even have to interact with your application if it's infeasible for them to do so. They can just look through the documentation, if you will, that ad hoc automatic documentation, and they can give you feedback. Okay. So I think that's all I wanted to show you for creating coded UI tests from scratch. The next thing that I'll show you is just a simple workflow for creating them straight from Microsoft Test Manager. So in Microsoft Test Manager, I have a test that I created earlier. And for those of you that haven't used Microsoft Test Manager, this is a tool that's primarily targeted at manual testers. that are writing tests. So this allows them to write their tests, to map them back to functional requirements within your development project, and then run through those tests on a daily or weekly basis to make sure everything's passing. It's also responsible for giving the manual testers an easy way of collecting what we call actionable bugs for the developers. And so when we say actionable bug, what we mean is we want to automatically capture rich data like video recordings or IntelliTrace files or event logs, so that when manual testers are using this tool and they find bugs for developers, it automatically captures all that information for them, and you don't have this bug ping pong where you're going back and forth and saying, well, what build were you using? And, are you sure you clicked on that big green button? Because that's what's supposed to work, right? And so if you missed that and that's of interest to you, you can check out my recording from yesterday, which is online right now. So this particular test case I created just to have multiple steps in it, and we basically open up a website, we create a new customer. And so when my tester ran this test, the last time they ran it, I'll just run that manually because it's currently automated, but I'll show you what it looks like when they run it manually. They have this option over here that allows them to create what's called an action recording. And when you create an action recording, that captures essentially the same information that you captured when you ran the application using the coded UI test recorder, but it captures and stores it within Microsoft Test Manager. And that is an advantage to the tester because they can manually play this back and fast forward through the application. So it's still meant to have a user in front of the computer at that point, because there might be other parts of the application which are changing, and that playback logic may not work. But if you had a 30-step test case which was supposed to validate that you could add items to your shopping cart and eventually check out and pay for them and you get a receipt, and the only thing you're testing for this particular sprint is to make sure that the receipt looks correct, it's a big waste of the tester's time to make them create a new user, log into Amazon, add items to their cart, and eventually get down to the bottom where they're going to validate the receipt. And so this allows them to fast forward through the first, say, 25 steps and then finish the last 5 on their own. But eventually, once this test case reaches a stable state and it's passing on a regular basis, this might become a suitable candidate for automation. And one of the ways that you can set up this workflow to signal to your developers that you want to automate this particular test case is simply to right-click on it and open up that test case again and change the automation status from not automated to planned. That way you can set up a regular task on your development team to query for any test cases that are in your test plans and say, are there any that we should turn into fully automated coded UI tests? This one I've already done. In order to do that, what I did is I came back over to Visual Studio and I created a new coded UI test. In my project again, not in my solution. I'll add a new coded UI test, and then instead of recording it from scratch, we just point it at an existing test case. This is where you can set up a query if you want to look for any test cases that are in a planned automation state. There's the test case that is showing up as a candidate for turning into a coded UI test. We double-click on it, and then what it does is it turns all of those actions into code at this point that we can then start using to add assertions to as the basis for our coded UI test. And so that's pretty straightforward. The one thing that is important when your testers are recording that action recording is you should encourage them to mark each test step as pass or fail as they go. And that's the only way that we know to give you these individual methods. So each one of these methods basically corresponds to a test case step that was in this particular set of data. And the reason that that's important is it just makes it easier for you as a developer to understand what's going on within the test case itself, and it also makes it easier for you to maintain that moving forward. The other thing that you'll notice, of course, is that we automatically added that data binding for that test case. So if I was to come back to Microsoft Test Manager at this point and add an additional row of data, that would cause it to run subsequent times. Now, this is great to create coded UI tests that run on my local machine, but that's a lot less interesting than creating coded UI tests that run in a variety of environments, especially as you think about where your software needs to run in the wild. And so if you were in my session yesterday, then you saw me create a lab-managed environment. And there's a few different changes that we have within Microsoft Test Manager that allow you to create better lab-managed environments within Visual Studio 2012. And to understand that, let me first show you the workflow for lab management. This is a capability that we added to 2010 to start with, and the idea is quite simple. First, you check your code into Team Foundation Server, then you kick off a build process either every night or manually that pulls that build or pulls that code, builds it just like you normally do. At the end, you might be creating an MSI, you might be creating a project that you would web deploy or Xcopy over to a server somewhere. And then once you've built it, then we can spin up one or more virtual environments that consist of one or more virtual machines. And so I might have a virtual environment down here that consists of a web server and a database server, and maybe the web server is running Windows Server 2008 R2, the database server is running SQL 2008 R2, and then I spin up another environment that tests Windows Server 2012 and so on. Now, the challenge with setting this up in Team Foundation Server 2010 was you really needed to have a very complex architecture and perform a lot of manual tests to set up those images. And that's the number one thing that we received feedback on. A lot of people loved lab management once they got it up and running, but they said it's too difficult to set up for the first time. And so in this release, we've invested in simplifying it. Let me first just show you the architecture in 2010 so that you understand the changes that we made in 2012. In 2010, you had to have Team Foundation Server at the heart with Team Build, a test controller, and System Center Virtual Machine Manager. If you're not familiar with System Center Virtual Machine Manager, that is a product that's used predominantly by IT professionals to spin up new virtual machines that they might need in order to run the software that you're building for them. And so they might say, we need to spin up a new virtual machine based on Windows Server 2012 and SQL 2012, and it then goes out, fetches a library, maybe fetches a sysprepped image from a library, generalizes that onto a new machine, and then it handles the work of figuring out where that virtual machine gets deployed onto physical hosts based on where there's available processing power and disk space and so on. And then down here at the bottom where you set up the virtual environment, you also have to configure a test agent, a build agent, and a lab agent, and a VMM agent to then go back and talk to Team Build, SCVMM, and so on and so forth. And so this is really where we focused on making lab management much easier. You can still set up environments using System Center Virtual Machine Manager that give you a lot of unique capabilities that I'll talk about in a moment, but you don't have to configure these agents by hand. And in fact, we've collapsed the agent architecture down to a single agent. Now all you need to do is you point at a box. It could be running Hyper-V, it could be running VMware, it could be a physical box that's running that maybe even gives you access to hardware that you can't otherwise virtualize. You point it at that machine, you supply the credentials, and we just set up the environment at that point. That's what's known as a standard environment, so it's a lot easier for you to work with now. Now, there are, like I said, some unique capabilities of SCVMM environments. So if you want to automatically capture snapshots and be able to restore to a given point in time, like show me Friday night's build, that's where you still want to take advantage of SCVMM. And then you also can do things like set up network fencing. So if you need to replicate an environment that looks exactly like your production environment, and you need to do that 10 times to maybe have different test environments you can work with, one of the challenges you start to run into is that you start having the same IP address or at a minimum the same machine names that you're trying to replicate in production. SCVMM allows you to abstract all that away and set up literally identical environments regardless of whether or not they have the same machine name. But if all you need is to make sure that your code, builds and compiles and can be deployed onto a Windows Server environment, and your primary development desktop is Windows 8, for example, then standard environments give you a really nice opportunity to take advantage of that. And so if I switch back to Microsoft Test Manager here, if I drop down to what's called the Lab Center the Lab Center is where you configure all of these environments. And I've pre-configured this environment. I went through some of the steps yesterday, so if you want to see how this all gets configured, check out the last 15 minutes of my session from yesterday. But basically, this environment is pointing at another virtual machine on my box. It could be a physical machine somewhere that I have network access to. And the other thing that I've done is I've wired up this environment by describing a build, deploy, test workflow that first builds, then deploys, then tests all my code. Go figure. And so if I look at my build definitions in here, my build definitions give me the option to set up this build, deploy, test workflow and describe exactly what happens at every step along the way. And if you've used Team Build before, you would basically just use a different process template as part of your build configuration to do this. And so that's a lab default template that I've selected. That's one we ship out of the box for you. And then there's a wizard that allows you to define the properties, the first of which is what environment are you using. So that's the environment that I set up. If you had multiple environments, like one for Windows Server and one for, I don't know, Windows Server 2012, you could set up multiple environments. This is where you would queue a build that's going to be coming out of TFS. That then gives you the specific project that you need to deploy. And then you can wire up the specific deployment scripts. And so this is the same way that you deploy your application today. If you deploy your application today by running a SQL script and then doing an Xcopy or a web deploy of your web project into IIS, then you would basically do the exact same thing here. We also give you some capabilities to set up parameters. The only reason I'm showing you this is that this is very important sometimes for coded UI tests, because as I mentioned earlier, if you need to change your coded UI test based on the environment that you're deploying into, so if you have a different machine name and you need to access a website off of that machine name, this is where you can do it, because the lab management environment at this point is aware of the machine name of every machine within that environment, even if you were to generalize it out of a sysprep when you first started this environment. And so what you can do is you can take the machine name and you can pass that in as an argument so that you store that into an environment variable or into an INI file somewhere. And then in your coded UI test, when it's being initialized, you would just go fetch that environment variable or fetch that INI file so that it knows what the address of the web server is within that environment or whatever you needed to program at that point. The one last thing that you do in here is you just set up what you want to run as part of your tests. And so here I'm pointing at a test plan, which was configured within Microsoft Test Manager. And if you have Visual Studio 2012 Premium, which is Premium or Ultimate, which is required to write coded UI tests, you now actually have a license that gives you capabilities to work with Microsoft Test Manager as well. So that's actually included when you buy it now, which was not the case in 2010. And so what you can do is you can configure that test plan like I've done here. And then when I come over to Microsoft Test Manager with this particular test case, if I open up that test case, which I believe is work item 81, you have to open it in Visual Studio, but then you can go into the associated automation tab. It's read-only in Microsoft Test Manager. That's the only reason I'm in Visual Studio. You go into the associated automation tab, and you point it at the test method that describes how you're going to automate this test case. That could be any type of test method. It could be a unit test. It could be a web performance test. It could be a load test, and of course, certainly a coded UI test as well. And so to show you this running in action, all I need to do at this point is come back to my builds, and I'll kick off a new build. Oh, it looks like my build controller tends to go to sleep whenever I hydrate and walk to another building. Give me 1 minute just to patch this up. This is a symptom of my virtual machine. Okay, we're almost there. And that's how you configure your team build. So now that you know how to configure a team build, let's queue off a new build here. All right, so that looks back online. We'll go ahead and queue that guy. And what it's going to do is it's actually going to kick off two builds. One is the build, deploy, test workflow, and then the other is the compilation of your original project. And so it's just going to go out and call a new build, which is what's responsible for building and compiling my .SQL file, and in this case, a web deploy project. And then once that other build has completed, then it has the payload that it needs to then spin up that build, deploy, test workflow across my virtual machines. And so if I minimize this guy, I can actually pop over to my other environment here, which is my lab guest machine. And so again, just imagine, if you will, that we are, let me change the resolution so you can see this. Let's say that we're using Windows 8 as our development environment, and we needed to make sure that our code would run correctly in a Windows 8 or a Windows Server environment. And that's all I'm doing here. So I'm running Windows 8, imagine, on my primary dev machine, and I just checked in a change, and I want to make sure that it shows up and the coded UI test runs correctly within this other environment. And so in a minute, you'll see this build agent actually come online, and as I mentioned earlier, the agents are now consolidated, so they're responsible for participating in not only the deployment infrastructure, but also running that test. So in 2010, you would not have seen it, say, deploying, but in 2012, it will also deploy and then run that test, and then, of course, report back all the results. And that's really important as well. Within Microsoft Test Manager, you have the option of configuring what are called test settings for your automated build runs. And so you can go in and turn on things like video recordings, for example. And once you turn on video recordings, you can actually have the video recordings enabled even if a test passes, so that you kind of get that other option for going back to review exactly what was taking place within your lab environment. Because you're probably not going to be watching these machines run in your lab overnight, but you might occasionally want to look at them just to make sure that everything looks correct. You can also turn on IntelliTrace files. So if you've seen IntelliTrace, that allows you to go back in time and actually check to see exactly what was taking place within the .NET execution stack. So if you threw and caught an exception, you could actually rewind and say, why did I throw this exception? Why did I get a null value? Well, it's because this parameter was set to null, and then these 10 frames earlier, it's because I couldn't actually access that database to pull in that parameter. This takes a lot longer when you're standing on stage in front of a few hundred people, doesn't it? So while we're waiting for the build to complete, does anybody have any questions? I think we have just 3 minutes here. No? Yeah. Is it possible to capture just Windows events, mouse clicks, and positions, as opposed to what? Oh, I see. Yeah, so I think what you're asking is, the common reason people ask that is if you have a control, like a flash control, that actually is not, doesn't provide the accessibility hooks that we need. And in that case, what you can do is you can go through and effectively record the XY coordinates. It's going to be much less robust at that point, of course, because if you do change the way that that flash control works, then you'll have to re-record those XY coordinates. But yes, you can do what you're asking. In that case, we would just look at that object control. We would record everything you're doing from an XY perspective, and then we would play that back. Yeah. How do you maintain the coded UI map when the UI changes? Unfortunately, there's not really an automated way of doing that. You do have to go in and manually re-record the way that the UI map works. So as you've seen, we do a lot of stuff in here when we can to actually make sure that we're manually, or we're automatically giving you fallback parameters, or using those search and filter properties to look for specific controls in a variety of different ways, so that we hopefully find them even if you change the name or the position or the relative place within the hierarchy. But oftentimes, you're right, if your application gets rewritten from scratch between V1 and V2, then you might need to go in and re-record everything. Yeah. I think my build service is failing me today. This worked yesterday, I promise. Those of you that were in my session yesterday saw it. Yeah, in the back. Yeah, that's a really great question. So what he's referring to is a new capability in the Microsoft Test Explorer within Visual Studio. And if we come back over to Visual Studio, you'll see that here. If I open up the Test Explorer, there's a little icon up here in the upper left that allows me to run tests after each build. And there's actually been some debate as to whether or not we would apply that to coded UI tests. Right now, we do. And what that means is that every time you just do a Control-Shift-B on your application, it's going to run all of your coded UI tests and your unit tests, which is probably not something that you necessarily want. And so if that's something that you are doing in your projects, you should consider possibly turning that off or sending feedback to my friend Peter Provost and letting him know that he needs to differentiate between the type of test. Right now, because the unit testing framework is extensible and we let anybody build testing adapters for XUnit, InUnit, and so on, they actually don't have a level that allows them to opt in and out as part of that interface, but that's something that a lot of people have asked for. I think there was a question here, and then I'll stick around afterwards. Yeah?
You mentioned that we need to pull back to Visual Studio 2010 to support Silverlight 4.
Yes, right now. The question was if you wanted to support Silverlight 4 for coded UI tests, you would have to use Visual Studio 2010 with Feature Pack 2. Silverlight 5 is something that's in process, so the team is working on that. It's not, my understanding from what I've been told is it's not going to make it for RTM, but it's something that they're kind of doing as a nights and weekends project to hopefully ship something shortly after RTM. So yeah, it's a good question. I am out of time. I'm sorry the build didn't run. It usually runs. So go check my session from yesterday if you want to see that. It works, I promise. It's just a VM limitation. I want to personally thank you all for having me at TechEd Europe. I've really had a great week interacting with you, and I hope I'll get invited back next year. So please take the time to fill out those eval scores. I really do read through them. And thank you very much for coming. And enjoy the game tonight, again, in this room.